So everybody, I'm here with Professor Peter Cox today, and he is the director of the Global Systems Institute at Exeter University. He's fantastic, and he's going to be running us through 2023 and the extreme weather events and what exactly it means for the climate. So Peter, I'll leave you to it. Thank you very much.
Thank you. Oh, good. I wonder if I can scroll through this. Maybe not. Okay, morning, folks. Bit of a problem turning over slides here. I think I'm going to have to share again, and oh, maybe it's this one here. Can you see that, Ruth?
Yep. So we can see your first slide, Peter.
Yeah, it won't scroll on this one. I'm going to have to go in and out again.
Okay.
But I have to stop sharing and then share again. Excuse me, folks.
Okay. Technical difficulties always the way.
Yeah. Climate system's easy compared to this. Share screen, just a second. Right, hopefully you can see that now, Ruth.
Okay. Yep.
Great. Okay, folks. So, first of all, great pleasure to be here. So I've been asked to speak about 2023, the climate in 2023, which was extraordinary in many ways. And it's a story of sort of two sides. So part of what we're seeing is just the inevitable consequences of increasing greenhouse gases, especially carbon dioxide in the air. And sometimes we get a year like 2023 that kind of slaps us around the face and says, wake up, it's time to act a bit more quickly. So very pleased to talk to you about this. Some aspects of 2023 are therefore kind of as expected, but some are not. And there's a combination of things that seem to have gone on last year and have continued into this year as well, into 2024, which I'll take you through. The overall message of this, I hope, will be that the need for action has never been more urgent. And so I'm very pleased that you're getting together to talk about this in your sector. When we've gone through the presentation, which should only take about 15 or 20 minutes, I hope there'll be plenty of time for questions. Very happy to take questions from you. So the basic issue that we normally frame this in terms of is global warming. So that's the change in the global mean temperature. This is actually shown from 5 separate data sets, actually global data sets. So there's a lot of agreement. So these are basically temperatures taken by ground-based measurements like Stevenson screens you would have looked at some point, ship measurements of the ocean, aggregated up to work out how the global temperature, the mean temperature, has changed over time. And we typically start in about 1850. And you can see from this plot that prior to about 1970, there was quite a lot of variation. You know, there's actually a period called the mid-century cooling from 1940 to 1970. But from about 1970 onwards, there was an upward increase in global mean temperature that is quite extraordinary in the context of what the Earth normally does naturally. And actually, prior to last year, the 8 warmest year on record were all the previous 8 years. And then 2023 went even higher and broke the record for the global mean temperature over this 1850 onwards period. And we believe it's the record for much longer than that, because we have other ways to estimate temperatures going back much further. So this looks like an extraordinary year in many respects. You can also see there's an upward trend here, and it's part of an upward trend, but then you see spikes occasionally on top of the upward trend, and we'll talk a bit about that. So, I mean, I'm in the business of trying to model the climate system, so I'm going to tell you it's complicated. Ruth knows this from the lectures, that it is complicated. There's lots of interacting components. There's lots of things that can change the climate. Solar inputs one, greenhouse gases are others. There's natural greenhouse gases, there's human greenhouse gases. But actually, that global warming trend is pretty simple, actually, compared to the overall complexity of understanding of the climate year on year. It's actually pretty straightforward. And what's emerged over the last few years of climate science is that despite all that complexity, there is this extraordinary near straight line graph between, on the x-axis here, the total emissions that humans have put out since pre-industrial times, taking it from 1850, and global warming. And we expect this to continue into the future. So this kind of simplifies our problem, because even though there's all this other stuff going on, in individual years like 2023 have all sorts of things going on, the long-term trend is almost entirely associated with the CO2 emissions. And that's true in the past. That's the grey bit here, up to about 2020, and then onwards for various scenarios. That's true. So the bottom line is, and this is from the last Intergovernmental Panel on Climate Change report, every tonne of CO2 emissions adds to global warming. And so everything we're doing with regard to net zero is about stopping going up this line. When we stop emissions, then we'll stop going on the x-axis, which is the cumulative emissions, and we'll stop, therefore, global warming. And that's pretty much robust across many models and many observations. The problem we've had is that even though we've known about this for quite a while, global CO2 emissions have continued to go up. So this is an estimate from a paper that just came out. This shows the total emissions you hear reaching. So you can see here in the grey line, which says fossil plus luck. No, luck is land use change, so primarily deforestation, have reached about 40 gigatons of carbon dioxide per year. So that's 40 billion tons of carbon dioxide a year from human emissions. And you can see the components of this here: power sector in purple, industry in green, ground transportation, etc. The difference between the coloured blocks and the line is deforestation. So that's one of the things that's about 10% of our emissions. But the predominant reason CO2 is going up is because we're burning fossil fuels and continue to burn fossil fuels. The other thing to notice about this, if you look in about 2020, when we had the COVID lockdown, we actually had a temporary drop in global emissions, and it recovered, unfortunately. The good news is, and you can see this in the inset here, the global emissions are estimated to have gone up just marginally from 2023 to 2022. So CO2 emissions may be peaking now. They need to come down rather rapidly to stay within the Paris targets for avoiding 1.5, definitely 1.5 and 2 degrees of warming. But they are possibly plateauing and coming down the other side. We need them to come down very rapidly to avoid exceeding those Paris targets. But having said all that, so long-term warming predominantly correlated with cumulative CO2 emissions. That's why we need to get to net zero. But something else happened in 2023. And if we look at individual years, typically there are many things going on. The CO2 increase is not enough to explain all the change. There's other things that happened. This is just showing that global warming record again on the left. These are 5-year averages. So when we talk about climate, say in the context of the Paris targets to avoid global warming of 1.5 or 2, we're typically thinking about decadal or 5-year averages. What's shown on the right here is the annual anomaly from the mid-1960s onwards. And you can see how large the 2023 anomaly was compared to other years. In fact, the 1.5 target may well have been exceeded for the individual year. So this is the Paris target of staying as little above 1.5 as possible. It may well have been exceeded. In terms of the 5-year, 10-year mean, it's still about 1.25. So we haven't exceeded Paris in the context of the climate, but it just goes to show how you can get an individual year that will break through those barriers. The reason it happened is associated, the reason that spike happened is associated partly with the El Nino. So this is when the tropical East Pacific gets warm, and the ocean basically heats the atmosphere up and you get additional warming. We see this in general, I'll show you in a second, but when we get record years, it's global warming plus El Nino normally that gives it. But there are other things that went on in 2023 too that are only partially understood. So what this shows here is temperature anomaly by month. You can see in red 2023, and the colors code different decades. So you see as we've increased global warming, the lines have moved to higher temperature anomalies. 2023 was within the bounds up until about May 2023, and then it broke 3, and that's when El Nino entered the ENSO, this El Nino southern oscillation, entered the El Nino phase where the climate gets warmer in general, and it's carried on into 2024. You can see in the yellow. So the record is not normally associated with record CO2 levels which have had plus an El Nino. And my apologies a little bit for the size of the numbers on this plot, but you will see here in red are when these El Nino events occur, when the tropical East Pacific is warmer than usual. Blue is when it's colder than usual. That's called a La Nina. And you can see where all the record peaks are over the last, where we're going back to 1950, are associated with El Ninos. And 2023 was one of those. So we basically had global warming, record CO2 levels, record global emissions, but El Nino really giving that spike. And you can see that. So this is a plot now of the temperature, the warming of the ocean. And this is a peculiar thing that it seems to be extremely marked in 2023, and there's a slight worry. So if you look in the middle of this, we're looking at the Pacific Ocean. That red patch there in the tropics on the east, in the East Pacific, is really indicative of the El Nino. That's basically what goes on in El Nino. It gets hot in the East Pacific, and then you release heat to the atmosphere and get additional warming. But look also at what happened in the North Atlantic. Huge warming there, and the North Pacific. And there are lots of theories about what might have happened here, but it is peculiar. Typically, when we think about global warming, we expect the air temperature to be rather variable and erratic, like weather is. And the ocean is a slower, slightly more reliable beast, taking up about 90% of the extra heat we're putting in the system. But something extraordinary happened in 2023 that led to the ocean being record warm. And that's unusual compared to other record years. So when we get El Nino events, we do get this warming in the East Pacific, but not that extent of warming in the North Atlantic and the North Pacific. The other thing that happened is that we saw record lows in Antarctic sea ice, so Southern Hemisphere sea ice, by a long way. And that's also something that's unusual. The Antarctic sea ice seemed to have entered some sort of phase of being much more variable, which we sometimes think is indicative of the system becoming less stable. And there's various reasons why this might have happened, but 2023 again had this rather extraordinary coincidence of various things with warming of the ocean and sea ice declines, as well as extreme weather. And let me come to that now. So one of the things that we are seeing more and more with climate change is that associated with global warming is increasing number of climate and weather extremes. This is from Gallagher Reinsurers, and this shows instances of where natural catastrophes occurred in 2023. What you'll notice in the green, these are severe convective storms, so basically thunderstorms. You can see how they were particularly prevalent in southern US. And you can also see flooding in the light blue, and sometimes things like wind, fire, which are associated with droughts. So the thing about 2023 is it wasn't record losses overall due to natural catastrophes, but it was the record number of 1 billion plus climate and weather disasters. So we can see more and more that with global warming and with temperature increases, that we do tend to see extremes changing too. And that's arguably the most important thing for a lot of us, because it's these extremes that hit us hardest and have the largest economic and human costs associated with them. So there is a need for us to get climate change under control, not just because it leads to things like sea level rise, which is continuous and has an effect on coast, but it also leads to storm surges that mean we get larger problems with coastal flooding. It leads to increased rainfall intensities when it rains, because the atmosphere holds more moisture and there's more energy in the atmosphere. So that's the convective storms. And it's basically leading to a larger and larger number of losses. So there's an issue here about how we avoid this getting worse, which of course is about getting to net zero as soon as possible, but also about becoming resilient to these sort of extreme events, which are likely to become more common. So I'm going to summarize now, and then we can go to questions. So 2023 was globally the hottest year in the observational record. So going back to 1850 and probably long before, it's about 1.5 degrees above the pre-industrial global mean, which is of significance because of the Paris Agreement. It isn't how the Paris Agreement is framed. It's not about individual years, but it is indicative of the fact that it's the first time we've exceeded that 1.5 value in the observational record. Probably about 1.2 to 1.3 in the sort of climatological decadal mean at the moment. And we probably have about another decade or so at current emission rates before we pass through 1.5 in the decadal mean. What was unusual was the ocean, which is normally a much more slow to respond part of the system, a much more reliable part. especially the Atlantic, was peculiarly warm. Antarctic sea ice was also at a record low. And as I said, there were a record number, actually 63, 1 billion plus climate and weather related disasters in 2023. So a connection here between global warming and extreme weather and vulnerability to extreme weather. At the moment, it looks like it's partly due to greenhouse gases. So as I said, emissions were at the highest level ever. CO2 is the highest level ever, probably the highest level it's been since modern humans have been on Earth, existed. There was El Nino event effect as well. And the other thing that's happening in the system at the moment is that the planet is getting darker from space, which means it's absorbing more sunlight. This is probably due to the fact that we did a good thing and we cleaned up the air quality. And in 2023, there may have been an impact of removing sulfur from shipping fuels, which was a good thing to do also for coastal communities, but has an impact on global warming. So these three things seem to have come together to make 2023 peculiar in many respects, but also part of what we might expect in the future. That's often what climate scientists say. Every year can do things that surprise us, but they are on a trend that is consistent with what we think if we don't deal with CO2 emissions, greenhouse gas emissions in general. And I think just this takeaway is that it was a record-breaking year, very interesting from a climate point of view, but also worrying. So I think it will probably stick out as a record year for a while because of the El Nino. 2024 might get close, but we still need to wake up to the fact that we've been aware of the climate problem for properly since the late 80s. Before that, for some people that were very insightful, but actually we continue to increase CO2 in the atmosphere to record levels. So we need a greater degree of focus on this problem. And one of the nice things about the problem, in a way, people sometimes say to me, well, how do you go about your work? Well, first of all, I'm a scientist, very interesting to study a system that's changing. That's a sort of slightly scary thought. But the second thing is, it is a problem that we all share, humanity shares. And so solving this will require us to work together. And that will be a really good thing. And I'm going to leave it there, Ruth.
Thank you so much, Peter. That was fantastic. And I think a really good overview of all the main quite complicated factors involved in 2023. So I think we've got quite a few questions coming in. So I'll start from the top. So the first one is about the Gulf Stream. So there were quite alarming reports last year about the Gulf Stream shutting down potentially as early as 2025. Should we be worried?
Yeah, I mean, I think those were a little bit overplayed because the Gulf Stream is a relatively slow part of the system. We have had warnings that the Gulf Stream is declining, and we do expect it to decline, basically because of freshening of the waters, especially from ice sheet melt. So we are expecting to slow down. I don't think that analysis was done with basically looking at the resilience, the variability of the system to work out whether it might change. I think we are possibly going to cross a threshold, but there are long timescale tipping points in the system where there is a possibility to overshoot a bit. We should be concerned, but I don't think it's the bigger concern. I think is the fact that the extremes are increasing so rapidly and the extremes hit us so hard. So yes, I mean, all these tipping points are of concern to us, especially at Exeter. We study them a lot, but I think some are fast and some are slow. And the Gulf Stream or the AMOC, the Atlantic Meridional Overturning Circulation, is one of the slower ones. So do need to keep an eye on it. It will likely change, but I don't think an abrupt switch off is likely.
There are more pressing things to be worried about then.
I think so. Yeah. I mean, I think it's something to keep an eye on for sure, but I don't think it's going to be the first thing that really hits us badly.
Yeah. And so this is a bit of a political one. So what do you think about the UK government handing out new North Sea oil licenses and about Labour's intent to not revoke them? So is there a method in the madness?
I don't think so. I think it is madness, to be honest. I mean, if you set a net zero target that is so challenging, and then you do something that really goes against it, the issue with climate change is that whatever else you might do, offsetting, for example, is one case. The best thing you can do, in fact, the thing you must do, is to leave as much fossil fuel in the ground as possible. So digging it up and burning it goes against everything that we need to do if we're taking net zero in Paris seriously. I don't think there's any doubt. Climate scientists wouldn't disagree with that at all. It's just a crazy contradiction, really. And sometimes, quite often what happens is economic concerns trump. I'm sorry, the term Trump is probably inappropriate in some ways appropriate. Trump environmental concerns all the time. And we're going to run out of time to make sure the environment is there to support our economy. So, it's a very disappointing thing that, that's all I can say about that.
Thank you. So will reaching net zero prevent the extreme weather events that we've been seeing? So it was actually a question from me. So even if we hit net zero, will we still be seeing these extreme weather events for quite a long time afterwards, or will they?
Well, so it's an interesting thing. In a way, so compared to before we started emit emissions, we will still see more extreme events, but they should stop increasing. So one of the interesting things is that there's a sort of cancellation here between when you get to net zero, carbon dioxide temperature carries on going up because it takes a while to warm up the ocean, but also carbon dioxide comes down because it takes a while for the ocean to stop absorbing CO2. So the net effect of this is a really interesting simplification of the system that, to a good approximation, when you get to net zero, you stop climate change. And that's something that's emerged over the last few years, mostly when we do, as you know, Ruth, when we do climate change research, we make it more complicated, but this one made it really simple. It's kind of like when you stop that, you can worry about small amounts, but the bottom line is you stop climate change. So net zero, hugely important, and sometimes undermined by the misuse of the concept, but actually from a scientific perspective, it's sound. It's a really sound concept. So we should try and hold on to that if we can, even though it's under pressure from various sides.
Yeah, and that's something I suppose that's Alice asked about, if there is actually hope and how can we stay hopeful. But that's quite like you said, quite something to hold on to, isn't it? That actually, if we do hit net zero, it will stop climate change, and that's all
there is progress being made, actually. I mean, the transition towards renewable energy is happening. It's never quite as fast as we'd like, but the thing about global warming is that there isn't the framing of Paris suggests that there's no risk, no risk, no risk. Then you go above 1.5 and it's terrible, or you go above 2 and it's terrible. It's not like that.
No,
actually. I mean, the risk just increases with global warming. So you want to keep it as low as possible. 1.5 is better than 1.6, but 1.6 is better than 1.7, etc., etc. So we mustn't get to that point where we give up on it. And as I said before, I think there's hope because it brings people together, like this group of people, to talk about things that they can work on together. And that bringing people together is a very human thing. In this case, it's required, and that's a good thing, I think. I'm not depressed doing my work, as you know, Ruth, because I think it is something we all share an interest in. And then, well, even if we're not interested in it, we ought to be. We have a sort of vested interest in it, even if we don't know that we do. So, yeah.
Yeah, benefits us all, doesn't it? If we all try. Thank you, that's fantastic. And a question from Helen Lockhart. So do you have any graphs showing the ocean temperature over time? So I'm aware and understand that the ocean is generally heating, which would therefore increase the frequency of El Niños. Is that correct?
Not the frequency of El Niños necessarily. So El Niño is a kind of natural oscillation in the system. It's got 3 to 5. It's approximately quasi-periodic, it's called. So it's got a 3 to 5 year cycle in it. We are looking out to see whether El Niño is going to get stronger. I think the jury's still a bit out on that, Helen. I don't have graphs with me, but I can send you some on the ocean temperature over time. So the ocean temperature has been going up, but this was a peculiar year in the ocean, and it can only be variable like that if the warming is near the surface. So generally speaking, the heat penetrates into the deep ocean, and it's a much slower response. And it's been slowing down global warming for us. As I said, it's been absorbing about 90% of the heat of the ocean. So there's all this water, high heat capacity. So I think the issue about El Niño is still a bit out, but I don't think there's any clear message from the models on how El Niño will change. There are patterns of warming that look a bit like El Niño, but they're not El Niño themselves. They're just patterns of warming that have that warming in the East Pacific. So at the moment, we're thinking global warming plus El Niño, when you get an El Niño, can be damaging. For sure it can be. La Niña can also have its problems in different parts of the world, the opposite. We don't see strong evidence for the variability changing, but it is adding to the stress on the system when it happens.
Thanks, Peter. And Helen's actually from the Two Oceans Aquarium, so that's why she's particularly interested in the ocean graphs. So that would be great if you could send over some graphs. I can put.
Yeah, and Helen, if you want to contact me separately, if I forget to get back to you, then please do, and we can also have an email exchange about that.
Thanks, Peter. And a question from Ella. So these anomaly years like 2023, how often do you see them in those graphs over time?
So we're seeing great, basically records. It's a good bet. Okay, maybe this is the way to say it. You get a chance to bet, and you have a reasonable estimate of when the El Nino is coming, and there is some seasonal forecasting that gives you that a few months ahead. Then there's a good chance that with CO2 continuing to go up, the next El Nino will be a record. That's basically how it works if it's a big El Nino. So what was, you have to remind me what the question is, Ruth. Sorry, I just lost that.
How often do we see anomaly years like 2023?
Yeah, so not very often. So that because this was a big El Nino and there's some other stuff going on in the system at the same time, this is a peculiar one. We had a very big anomaly because of a big El Nino in 97, 98. And for a long time, climate skeptics were saying it's been cooling since 97, 98 because there was a big peak. Actually, if you looked at the long-term trend, it was always going up, as you could see from the plots I showed. So we will get records if CO2 continues to increase, as it has been, when we get a large El Nino, and they can occur. El Nino occurs about 3 to 5 years. A big one probably occurs on average about 15 years, maybe something like that. So expect global temperatures to be broken, but not normally by this amount. That's when you get a large El Nino as well.
And another El Nino related question, Peter. So from Tudor. So do you have any thoughts on what the impacts will be on Europe's weather for this year?
Normally, Tudor, we think of El Nino as having a relatively little impact on European weather. But I suspect what we're seeing, we will see the impacts, especially of the warm Atlantic, which is not part of El Nino, but is connected to 2023 anomaly. So normally El Nino has a relatively small impact in the Northern Hemisphere, especially in Western Europe. But I think the Atlantic warming will have an impact, and we may be seeing it already. So there is an oscillation in the Atlantic, sometimes called the Atlantic Meridional Oscillation, which is a decadal thing when the North Atlantic gets warm and then alternatively cold. And that moves the intertropical convergence zone in the tropics up and down, and has an impact on rainfall in the tropics, but also has a knock-on effect on our weather systems. So I think bit of a roundabout way to say this, Tudor, but I think we're going to be more affected by the Atlantic warming than by the El Nino. But you can check me on that. It might turn out to be not the case. Normally it's El Nino doesn't have such a big impact, but Atlantic definitely does, where our weather comes from, especially in the west of England where we are now. Where I am anyway.
And it's very just wet and miserable all the time, isn't it, Peter?
At the moment it is, yeah. And there's some nice papers we can look up on that, Ruth, at some point on what we might expect.
Great. Yeah. Okay. And this is a question from Paul, and I hope you know what Paul means by this. So he says, thanks, Peter. Are you able to comment on how we are tracking RCPs, particularly the outputs? Which trajectory are we on?
Yeah, that's a common question, Paul. So the RCPs are representative concentration pathways. So these are basically possible futures. And you may, in that plot I showed of global warming against cumulative emissions, the RCPs were shown on that. They're more recently been named as the SSPs, shared socioeconomic pathways. But essentially what they are is possible futures that span a range from all the way from staying below 2 degrees to burning all the fossil you can get your hands on. It's difficult to know year on year, but I think we are now at least off the high one, 585, in terms of emissions. When you get an individual year, you can imagine you've switched from one to the other, but actually it's generally variability. The business as usual one, for want of a better word, RCP 4.5 or SSP 245 is probably the one we're closest to at the moment, but we need to get down to RCP 126. Sorry, these are terrible names, aren't they? So, the one relates to the socioeconomic future we're looking at. So that will be a green, sustainable future with a lot of cooperation. And the 2.6 relates to how much extra power we're going to be putting in the system of greenhouse gases maximum. RCP 126 would keep us below 2 degrees in most models, or close to 2 degrees. So it's what we have to do for Paris. We are probably on 245 at the moment, Paul, and we have to bend the curve so we get onto 126. And the longer we leave it, the sharper we have to bend it, because the interesting thing about that simplification I spoke about, Ruth, is that it doesn't really matter when you emit the CO2. There's only a certain amount you've got, which is why we talk of carbon budgets and net zero. So even net zero can sometimes lead you to believe, as long as I get to net zero at the right time, I'm going to be fine. Actually, you have to get to net zero so that the cumulative, the integrated emissions, the total emissions, are consistent with a particular target. So probably on 245 or RCP, what do we call that? 4.5, moving hopefully towards RCP 2.6, Paul, but we're not getting there yet, and it's a bit slow. The slow parts of the system we've spoken about in the climate system, but the economy also seems to be rather slow to make a transition, and we are hoping that the sort of things we worry about in the physical climate system, tipping points, these abrupt changes, can also happen in the socioeconomic part of the system, in the innovation part of the system, in the behavioural part of the system, the human part, in order to get us there. And I think there's reason to believe that is very often the case, that transitions can happen in the human realm even more readily than they do in the physical one.
Thanks, Peter. And a question from Anna. So are there any reference papers on weather trends to be expected in the Middle East for 2024? So the spring in Saudi Arabia and the UAE has been unusually rainy, as seen in the recent floods in Dubai.
Right. Yeah, I mean, extraordinary, wasn't it? I don't know of any, Anna, but I'll look out for those. I mean, sometimes what you'll find is, because papers take quite a while to publish, that looking at preprints or even blogs, you might get some information on that. I don't know the answer to that, but I'll try and find out for you. And please, again, you can email me if you want to remind me to have a look at that. It's an interesting question. Generally, weather is really hard because it just, the weather's variable anyway. So you can get events like this, but oftentimes when you get really peculiar extremes, it is driven by something like oceans being unusual temperature, and often warmer than usual. So I'll have a look at that. So I don't know of anything, Anna, but I'm sure work will come out about that. And if it doesn't, well, maybe someone should do the work, so we can ask them to.
And a question from Charlie. So are there any areas of climate science about which you and your colleagues at the GSI disagree? Any areas of climate science that the jury's still out? And I can think of a few that you've just mentioned throughout the year. So are there any that you're allowed to share?
Oh, I can share lots. We disagree about all sorts of things. I mean, basically, scientists like disagreeing. That's sort of what drives us. So we disagree sometimes about the causes of things, because we don't know. So with 2023, you'll talk to some scientists, they'll say it's just global warming. Others will say it's just El Nino. Some will say it's to do with removing sulfur from shipping fuels, and that's made the North Atlantic warm. It might be a bit of all those things. So we disagree about those. We also disagree about what should be done. So and views change based on what you've learned or what you've been exposed to in terms of opinions that might be counter. So one thing is, to what extent, for example, do we favour offsetting, and how should we do it? And we've had long debates about that in the university in general, about how much offsetting we should do. In general, we come to the conclusion it's much better to leave fossil fuel in the ground. That's basically it. Once you take it out and you put it in faster stores, it's sort of in the active part of the system, and it's more vulnerable to climate change. So there are lots of things about that, and that disagreement and that interest in discussing is partly what drives us forward, I think. So it's not, we don't want everyone to just agree on a particular line, but of course where we can just see the information and accept it as information, that's helpful. Sometimes you get people that just want to deny the information, so that's often not helpful. But what we do about it is still very much up for grabs, and it has to be a collective decision in your organisations, in nations, across the globe, in what we do about these things. And that sometimes can paralyse us. So I think the key thing is to be doing something useful on this as soon as possible, and not get too tied up in this versus that. And oftentimes we need to do everything really to get there. we're going to need to do a bit of everything.
And I suppose that kind of that leads me on to a question about the deniers and the people that don't, don't agree or don't necessarily think climate change is as big a problem as it is. Do you have any sort of, is there anything that you could say that could convince people? Is there anything that, because there's a lot of reasons and, some are more valid than others for thinking it's not as big of a deal as it is, but do you have any comebacks?
Sometimes, I mean, in some cases, of course, people, there's a human thing in a way to deny things that might, you imagine, lead you to have to change things you don't want to have to change. So I would be tempted to believe that flying on aeroplanes was good for the environment because it means I could do it, and I'd like to do that. But there are some things you just have to accept and you have to change ways of doing them. So there are aspects of skepticism that you just can't really deal with because, well, you can deal with, but it's not always fruitful in the sense that there's a conspiracy element to some of this that means the better your arguments, the more people are convinced that you're trying to trick them. And that's just a human thing, actually. I think what is happening is that old-fashioned skepticism, which is like denial of the global warming record, or that CO2 is a greenhouse gas, or even ridiculously that CO2 is not going up because of human emissions. Some people still were holding on to that a while back. Those things can be dealt with, and we've spoke about that, Ruth, in the course, is that, there are frequently asked questions that you can answer quite clearly now. People don't have to accept your answers, but there are clear answers to them. I think we have got another problem at the moment, which is catastrophism. And I know that sounds a bit rude. So there's a tendency for people to think there's no hope. And that's partly because of the way we've framed the problem in order to motivate action. So we talk about there being dangerous levels of global warming, implication being that there's nothing dangerous here, and then suddenly it gets really dangerous. Not like that at all. As we said, it's a continuous increase. So I think there is a need for us also to counter a fatalism that comes out with a view that the world all ends at 1.5 or 2. Two reasons for that. The people that are suffering from that get really low and suffer mental health problems because of it. But also they tend to be frozen into not acting. So we tend to think, well, if we're going to avoid 1.5, well, let's just forget about it. And that's not helpful. So I think we're going to have to start to think a bit more generally about minimizing global warming is what we have to do. There is no drop dead level in general. I mean, there are for individual organisms sometimes in some locations, and extreme events can do that. But in general, there isn't a point where it goes no risk, infinite risk. It's not like that. But it has been framed like that. So I think there's the countering of skepticism has been quite effective. We do have a problem with catastrophism now, which I want people to care enough to want to do something, but not so much that they're petrified into doing nothing. And that's a tricky thing.
Yeah. And I just one more quick question, Peter, and then I'm afraid we'll have to go. But if you could give one takeaway headline, what would it be?
Climate change is happening, and we've got to act on it, and we've got to act on it faster, and we can do that. Collectively, we can do that. We just have to have the intent, the proper intent to do it. It's an opportunity. It's an opportunity for us to work together in a way that humans aren't normally very good at.
But we can is the point. It's not too late. Yeah, fantastic. Well, thank you so much, Peter. Thank you everybody for joining us. Anybody that wants to get in touch with Peter, just feel free to reach out on the platform or get hold of me, and I can put you in touch. Thanks so much, Peter.
Thank you. Thanks very much, Ruth. Bye.